Hello, I'm Mr. Matt, and it's time now for topic 1.4. We're going to continue with AP Statistics, the new curriculum. And this topic is about graphical representations for one categorical variable. Now, if you recall, in section 1.3, we talked about how to represent the data for one categorical variable using tables. We talked about frequency tables and relative frequency tables. All right, and in this section, we're going to talk about how to take the data from a table and make some sort of graphical representation of it. This section will be pretty short because there's only really two primary ways that we're going to talk about graphing data. The first is something that I believe you're probably pretty familiar with, bar charts. All right, bar charts or bar graphs. And with a bar chart or a bar graph, we're going to display the frequencies, the counts, or the relative frequencies, which would be proportions or percentages, of the observational units in each category for a single categorical variable. And in this type of graph, the height or the length of each bar represents the frequency or the relative frequency of the observational units in that category. So let's look at an example here. Okay, here we have a bar graph, and this bar graph is for a single categorical variable, all right? And that categorical variable is marital status. Marital status. And in our table for marital status, we had 4 singled, 4 married, 4 divorced, and 1 divorced and 1 widowed. So in order to make that a graph, we simply just make a graph similar to this one where we have the height of the bar for singled goes up to 4. The height for the bar for married goes up to 4. And then the bar for divorced is 1, and the bar for widowed is 1. And this is a graphical representation of the data that was in our frequency table. Now, of course, this is a frequency bar graph. It shows the count, but we could very easily make this a relative frequency bar graph. So here, now I've changed it to relative frequency, and it looks pretty much identical to the one up here. The only difference is that our label now is in proportion. So 0.1, 0.2, 0.3, 0.4. And since there was 10 total, 4 divided by 10 is 0.4. So the height of this bar is 0.4. And the height of the married bar is also 0.4. And then divorced is 0.1, widowed is 0.1. So it's very simple. We have a frequency bar graph, and then we have a relative frequency bar graph. Not much of a difference. Pretty simple to understand, I think. And really, there's only one other way that we are going to be using to represent categorical data using a graph. And that's something that you probably are also familiar with, is called a pie chart. Now, for pie charts, we usually do it with relative frequency or percentages, but you could do it with the frequencies or counts as well. And here we have the definition of a pie chart. It is a chart or a graph that displays frequencies or counts or relative frequencies, proportions or percentages of observational units in each category for a single categorical variable. Okay, so once again, our single categorical variable that we're going to be looking at here is marital status, the same as we did above. So we're basically going to take the same data that we had above, but we're just using a different way to represent it. Now, notice that the area of each slice represents the frequency or the relative frequency of the observational units in each category. So up here, it was about the length or the height of each bar was representing the frequency or relative frequency. But here it's the area of the slice of the graph, okay? So we can see here, widowed has 0.1, so it's about 10% of the entire area. And then here we have 0.1 for divorce, which is about 10% again, and 40% for single, and 40% for married. So this data is represented using this pie chart. And of course, we want to have a key. Up here, we also need to make sure that we label everything carefully. Now, one thing that I do want to quickly mention is when we are doing bar graphs in statistics, it's important that you remember that we should always put a space between the bars. Sometimes when you are young and you are learning how to make bar graphs, some people like to put the bars stuck together, all right? Bar here, bar here, bar here, all stuck together. But we want to avoid that. And you'll find out why a little bit later we want to avoid that. But I just want to let you know to try and make sure that you always have some sort of space between each bar on your bar graph. So we have a bar, space, bar, space, bar, space. Okay? All right. Now, we've covered pretty much everything that we need to in this section. It says here we can use frequency and relative frequency tables, bar charts, pie charts to compare different sets that have the same categorical variable. So if I had people in Beijing, their marital status, and then I had people in Shanghai, their marital status, I could use two pie graphs or pie charts or bar graphs. I could put them next to each other and I could compare the two to be able to compare the distributions of those two categorical variables for these two different sets of data. But you need to make sure that we're using the same categorical variable, marital status in both of them. Okay, so we're going to move on now to just do a few practice problems. And these should be pretty simple. It's just about, can you read some simple bar graphs and pie charts? The first question says, a group of middle school students were asked which school subject was their favorite. The results are displayed by grade of student in the following bar chart. Okay, so in this one, it's a little bit different than what we did above. This is what we call a side-by-side bar chart or bar graph. And we'll talk more about this when we get to when we start talking about looking at multivariable data sets or data sets with one variable but from two different groups. All right, but here it shouldn't be too hard to understand. This kind of lighter color bar is representing grade 8 students, and then the darker color bar is grade 7 students. So now we have some choices here. Which of the following statements is supported by the bar chart? All right, so which of the statements that we are going to read is consistent with this bar chart? A, for students who choose art, the number of grade 8 students was at least 100% greater than the number of grade 7 students. B, for students who chose social studies, the number of grade 8 students was at least 100% greater than the number of grade 7 students. Choice C, for students who chose science, the number of grade 8 students was at least 50% less than the number of grade 7 students. And choice D, for students who chose math, the number of grade 8 students was at least 50% less than the number of grade 7 students. All right, so look at those choices and see if you can tell what the answer is. Okay, well, let's look at it real quickly. For students who chose art, so we're looking at these students right here, the number of grade 8 students is at least 100% greater than the number of grade 7 students. Now, 100% greater just means it's about twice as much. Now, looking at this chart, I think it looks like this A is correct. All right, let's look at the other ones. For students who chose social studies, that's this one, the number of grade 8 students was at least 100%. Well, it's greater, but it doesn't look like it's twice as greater. So I don't think that's the right answer. So we'll mark that one out. C, for students who chose science, the number of grade 8 students was at least 50% less than. No, it's less than, but it's not 50% less than. So it's not C. Okay. And then D says for students who chose math, that's these students, the number of grade 8 students was at least 50% less than the grade 7 students. Again, it's less than, but it doesn't look like it's 50% less than. So we'll go ahead and mark that one wrong too. Okay, so it looks like the answer is actually A. Okay, let's move on to number 2. Number 2 says residents from 5 districts of a city were asked whether they were in favor of a city proposal to create new bike lanes in the roads. The following bar chart shows the relative frequency in each district of those who responded that they were in favor of the proposal. All right, so it looks like in District 1, 0.4 relative frequency said that they were in favor. So that means 40% of the people that responded in District 1 are in favor. Looks like 71% or so in District 2. Looks about 55%, 62%, and then maybe like 46% in District 5. Okay, so let's look at the question now. It says, which of the following statements is supported by this chart? So which one is true? District 2 has the greatest number of residents who are in favor of the proposal. B, District 1 has the least number of residents who are in favor of the proposal. C, in 3 districts, less than half of the residents were in favor of the proposal. And then D, District 2 has the greatest percentage of residents who are in favor of the proposal. Okay, so which of those, A, B, C, D, do you think are correct? Which one is correct? Okay, well, let's look at each one. A, District 2 has the greatest number. Now, when you first read this, you might be like, well, yeah, District 2 has the greatest number. Boom. But remember, this scale that we're looking at is not the number of residents. It is the relative frequency of residents. This is just telling us that there are 71% of the residents in District 2 are in favor. If there is only 100 people that live in District 2, but 1,000 people that live in District 1, well, in that case, this would be 71 people, and this would be 400 people. All right. So you need to make sure that you understand that this is not the number of people. This is the percentage of people. So even though District 2 looks immediately like, even though choice A looks immediately like maybe that's correct, but it's not. Okay. So it's not A. So we will look at B. B says that District 1 has the least number of residents who are in favor. Well, same thing. Same thing. This is about number, but our graph only gives us information about the proportion or percentage. So this is not supported by the chart. In 3 of the districts, less than half. Well, here we have less than half. Here we have less than half, but these ones are more than half. So there's only 2 that are less than half. So it looks like C is also not true. So that leaves us with choice D. Is choice D correct? It says District 2 has the greatest percentage of residents. And that's true. 71% of the residents, 71% of the residents in District 2 are in favor. So that is the highest. So D is correct. All right, let's look at, we got a couple more problems. Let's look at 3. And here we have a pie chart this time. It says the following pie chart summarizes the results of a survey given to airlines about the primary reason for flight delays. So it looks like 70% weather, 15% overbooking, 8% runway closure, 5% other, equipment failure, 2%. Okay, which of the following statements is supported by the pie chart? Is it A, the reason given most frequently was runway closure? B, more delays were caused by weather than by all other reasons combined? C, more delays were caused by runway closure than were caused by overbooking? D, the combined percentage for other and runway closure was equal to the percentage for overbooking. Okay, so because this is a percentage of one population, so this one's a little bit different. You need to be careful with the comparison here. So even though this one is percentages or proportion, it doesn't give us information about the number because each of these districts might have different numbers of people in them. So 40% here might be different than 40% here. But in this one, we're only talking about one group of individuals or units. And that's the all of the delays. And so 70% of the delays are caused by weather and 15% were caused by overbooking. That means that a higher number of the delays was caused by weather than overbooking. So this one, we can equate the percentages and the numbers. Okay, so we do have information. So here it says the reason given most frequently was runway closure. And that's not true. Runway closure looks like it's only 8%. So that's not the answer. Next, more delays were caused by weather, 70%, than all the others combined. And it looks like these combined is going to be 30%. All right, we can add these together. 2 plus 8, 10, 15, and then 15 is 30. All right, and 70 is more than twice of, it's more than all the other ones combined. So 70 is more than 30. So this looks like it's probably correct. So we'll circle that. But let's check the other ones. More delays were caused by runway closure than overbooking. No. 15% to 8%. No. And then D, the combined percentage, combined percentage for other and runway closures was equal to overbooking. Well, 8 plus 5 is 13. That's not equal to 15. So that's not correct either. So it looks like the answer is actually B. All right, last problem here. Number 4. The following bar chart shows the relative frequency of days of rain for 30 days in 4 regions of a certain state. Okay, so we have 4 different regions, and then we have a relative frequency. So there could be different numbers in each region. So remember that this relative frequency data is not giving us information about the number in each of these categories. All right, next, which of the following statements is not supported by the bar chart? So be careful. Sometimes they will ask you which of these statements is supported. Sometimes they might ask you which is not supported. And so you have to watch out. Make sure you read the question carefully. So region D had the greatest percentage of days of rain. So yes, it looks like that one has the highest percentage, maybe a little bit less than 75, maybe like 74, 73. So that is supported. So that's not going to be our answer. Next, B, region A had more than 15 days of rain. Well, remember we had 30 days total, and it looks like more than 50% here had days of rain. So that means it would be more than 15. So yes, this one is true, which means it's not our answer. Okay, next, region C had more than 25 days of rain. Well, I don't know about that. It looks like this is around 30%, and 30% of this would only be about 9, all right? And it says more than 25, so I don't think that C is true, which means that it would be our correct answer. But let's check D quick. It says region D had less than 23 days of rain. I don't think that's true. We had almost 75% So that would be what? 15, 7, 22, 23. Yeah, so 75% would be 75% would be about, I'm sorry, 15, 22.5. So this is less than 75%, so it's going to be less than. So this one is true, which means it's not our correct answer. Okay, so C is our correct answer here. All right, so that's it. This is a pretty simple section. Just got to be able to read some simple bar graphs and pie charts. You probably have been doing that since you were in junior high and maybe even elementary school. So this is a section that should be pretty simple. I look forward to moving on to section 1.5 next time, and I'll see you there.